All right, well, it is 7 o'clock now. It is officially GIS After Dark, depending on where you are in the country or around the world. I would like to welcome you to part 2 of our Johns Hopkins speaker series. And this speaker series is hosted by the GIS program in the Advanced Academic Program at Johns Hopkins. And I am the program coordinator for GIS and Environmental Science and Policy. My name is Dr. Cassandra Hansen, and it's so nice to see so many familiar names and faces here from part 1. So let's go ahead and get started with tonight. And I want to remind everyone, the whole idea and goal behind this speaker series is to bring together GIS professionals to share their innovative ideas and approaches using the geospatial platform. And I am so pleased and excited to present tonight's speakers because we have 2 very talented Johns Hopkins alumni with us tonight. But before we get started for the speaker series tonight, I'd just like to take a poll to get an idea of who is here. So let's go ahead and launch the first poll to see who we have amongst the group tonight. All right, let's see who we have here. All right, so we see on the screen, excellent, look at that. We have a lot of Johns Hopkins students here. So I expect to hear a lot of questions for our speakers, to our Johns Hopkins alumni. We also have an alumni group that's showing up, excellent. We have a big group of other folks that are joining, and many of those folks here in attendance are in the GIS field. And even better, we have folks that are not in the GIS field, which is fabulous. So it's an opportunity to share what we're doing, how the innovation technology is being used. And so again, I would like to welcome you guys here. So the whole, like I said earlier, the whole idea behind the speaker series is just to bring together folks to really share workflows and ideas, innovating techniques. And so I am so pleased to announce that we have 2 Johns Hopkins alumni. We have Fizza Mustehsan, who graduated from Johns Hopkins, and she works as a GIS analyst at Orange County Public Works in the survey department, followed by Amanda Miner, who works for GIS as a GIS Service Manager at a company called Envicom Corporation. And both ladies tonight have a very different background in how they are using GIS to solve problems. So with that said, I am going to turn over the sharing capacities with Fizza. Fizza, thank you so much for being here. And let's give her our attention. And I want to hear some great questions asked by our students here.
Hi guys, my name is Fizza Mustehsan. I'm a GIS analyst with OC Public Works Survey Department in Orange County, California. I got my master's from Johns Hopkins. I started in 2016 as a part-time student because I have 2 kids, and I would do my homework in the car on my cell phone. And there was usually JavaScript in there too, and I would email a lot of my faculty all the time. So it was a wonderful experience with these people, and I'm so glad I went into this program because I had never thought that I would be in such a awesome field, which is so satisfying. So today I'm going to show you one of our implementations of GIS. I don't have or did not have much of geographic experience prior. I was a programmer part-time, and then I was raising family, and this was a good way to get back to a full-time job position. So when I came to the survey department, these guys were all about surveying and maps, and I was all about scripting. So there was a problem here that they wanted to quickly inventory the ADA access ramps. So let's see, let's go to the next slide. So this is the Americans with Disabilities Act compliant ramps. They are yellow with hard surface, gray with hard surface, some without any hard surface on it. And this little diagram in the corner, lower right, shows you the type of measurements that they wanted to take without going into the field. I will not go deep into that because that's, once again, not my expertise here, but I will quickly go over what I did to help them out. So the technology we used was, we had colorized Lidar data. We had 360 panoramic JPEGs. I used Esri, JavaScript, API. I also use the Photosphere Viewer API, and we use the Potree Point Cloud Viewer. I will go over them slightly with you. So this is the first stop is the Esri JavaScript API. My web app has like 4 components or so. This is one of the components. So this is a quick show that what kind of layers are on the map. There's an aerial base map. There's the ADA ramp feature layer. There's a photosphere feature layer. So this actually contains the 360 URLs, and there's a legal lot there. And then you see a little form that allows you to change the attribute information after the ramps are created. So the second thing we use is the Photosphere API. And this is, just, I'll go deep into it in the next slide, but this is just sort of like you click on that little cyan point on Esri JavaScript, and I open another pop-up and it shows you a 360 viewer. This I got from the Photosphere Viewer page. You guys are more than welcome to go on this URL over here, and it will show you this information. So some of the good things about it is that you can use it with VR and touchscreen. You can display markers. They displayed markers using texts and photos, but I even put maps inside it, but not for this example. You can also configure methods and events, and that helps you to do more cool stuff and add JavaScript code inside it, which I will show you in a bit. So this is a quick example of a Topo 360 web app. This is not the ADA ramp app. This is just to show you what I did with the Photosphere app, or what else it can do. The little red X's you see are the documented topo shot observation using Trimble. And the little flying saucers, the little blue thing you see, that's where the image was taken for the 360 view. So our team here, we use the horizontal angle, vertical angle, from camera to point, distance from the camera position to the point, and the direction of the camera to translate the real world coordinate system to the virtual coordinate system, which is within the sphere. And I'll show you inside, like on this page at the moment, you see there's a code. I used a marker here, and the code STPTR is striping, and then TCCN is a top of curve. So let me play a quick demo on how this thing works. I have Esri base map on the left lower corner right here. So each time I move inside the photosphere, it's going to move the base map, and the yellow plus signs are the points where the images were taken, which would be those pink, not the pink, I'm sorry, the blue floating icons. So you can move it around, and you can move forward, click on one of the spheres, and it will take you to that view. And you can again turn it around and have some idea to do some QA/QC work. So on and so forth. The other thing we use here is the Potree Point Cloud Viewer. This is a very lightweight, very responsive point cloud viewer out there. When I made this app, the Esri point cloud, I was unable to get the Z value. Each time I would click on a point, it would only be an XY and not the Z. And with the Potree point cloud, it's an open source. You can go in. I found a file where I could get the XYZ values each time I clicked on the map, and we were able to use it to get the XYZs. This is a quick example of what a point cloud is. It's actually a 360, or I would say a 3D image, I'm sorry, which is made out of small points, and each point has its own XYZ value. So when we are trying to do some kind of a calculation, you can just click a point and get the XYZ from there and put it in the mathematical formula. So see how granular this thing gets once you get closer. And when they collect the data, they do more than one pass. So you may have overlapping points, and you may have to be very careful when you are choosing a point to do a calculation. It is not meant for a survey grade work. It's more for a GIS standards. So here, I'm going to show you, I'm sorry, it's the same thing again. Okay, this one, we're going to go over the different tools inside it. So you have the angle measurement tool, there's a point distance, vertical and horizontal. They have area. They also have volume. And I'll show you quickly count of how it works. So this is just the viewer's inbuilt features. So for the angle, you just choose points, and it's going to show you the measurements. It's very responsive, it's very quick, and it's very fast. This is my favorite one, the point. See the XYZs? It snaps to the cloud around it, and it gives you a nice, accurate value. So this is the distance tool. You need 2 points. You can further click more and get more points. And let's see, one more. And we'll do the height next. Click 2 points again. And you sort of have some idea how, this works. I did not have a lot of time because we were in a rush, so I just used point to do most of my work for them. This is a way to get the area, and see, you draw, and you see how the area changes on each of your clicks with the, okay, cool, awesome. So here, now this is how the viewer looks like with the point viewer, the point cloud viewer, and the Esri API. The brown layer on the Esri map, which is on the right side, you click on those, and it allows you to choose a tile. And that tile populates the Anaheim, or we were using the Anaheim Island. It would populate the point cloud viewer with that tile. So I'll show you a quick demonstration of that as we go along the way. This is a create feature. So in order for these guys to find out where the ADA ramps were, they had to populate the cloud, and then they had to drive through it to find where the ramp was. So that's how the first ADA ramp was created. So they would go in, zoom around, spot one, click on it, and it will capture the XYZ value. So if you can see in the bottom, I don't know how small the fonts are. And there you go. So you see the XYZ value being populated in the bottom. They choose if it's a hardscape, yes. What is the type of DWS? It's a yellow ramp. Is there any obstruction? No. And now you want to add the URL that is a 360 URL. So if somebody wants to click on the feature again, they would want to see it. So the little cyan dots that are around it, I'm going to find the closest one that might be able to show me this ramp. So we click on that, choose one, turn around, find where it is, click on it. And there's a set copy button, which actually copies the URL. And I would paste it inside the URL 360 field, and I'm going to create a new feature, and then you'll see one being made here. There's already one present, but this is just created and another on top of that. Okay, so what is our, so this is showing you how I populated the tiles inside it. We're going to click on the tile there in the back. It says click a tile, and then it adds that to the point cloud. And now you click on the ADA ramp. So the calculation was done in a second go. So you go in and you need to find out where it's at on the cloud. So you hit Potree, it sort of puts a little point there where the location is. You kind of zoom in, adjust it, make sure you have a good view. And that's it. And I think in the next one, I'm going to show you how you do the calculation. Okay. So once we get there, you have to select 2 points, and then you can calculate the ramp slope, a ramp cross slope, or ramp width. So I use this tool, and that's how I grab the XYs. So I choose these 2 points, and I click on ramp slope. We put the formula in the background. It just takes the values. It does the measurement for us, and it checks if the standards were met. I'm doing the same thing for the ramp cross slope. You again need 2 points. And so once again, you may have to do it more than once because there could be more than one layer of point cloud at a certain location because if the car went a few times while they were trying to capture the data. And there you go. That's how we get the ramp width. So this is a correct way of doing it. I'm going to show you that what happens when that is not the case. So I tried my best to do incorrect job here. So we can see the red nose. Take 2 observations. And you do a check. It's a no. I'm going to repeat it again just to show you that with different variations, it will change. So that's it. And then I went again and I did the test for most of them. And there'll be another wrong one. That's it. Okay, so that's the app that's how it looks all together. We have the photosphere right here, our Esri JavaScript here, our Potree viewer here. This little bottom section, I did that myself. I put a little div on top of the Potree viewer, and I wrote code under each of these labels that would execute after it takes the XYZ values. And I guess that's about it. If you guys have any quick questions, and I'll see how much of them I can answer for you.
Thank you, Fizza. That was wonderful. I actually have a question while the group is formulating their questions.
Sure.
So how relatively new is this kind of methodology that you put together? How long has Orange County been using this way to collect data and make calculations with all the different applications together?
Basically, they were not using it for calculations. They had it for visual observations. And my habit is that I leave my desk and I walk around and see what everybody else is doing. And then I find out, oh, I can help you with that. Let's do this with this and we can combine this. So if somebody asks me the details of how the Potree viewer works itself, it's another guy's job, which I helped enhance. But this was the first time we ever used it to do an actual calculation. And after this, we used the same phenomena to do the guardrails. And with that app, I also added the Google Street View. So they would look at it, look at the photosphere, and they'll have the Google Street View, and they also could look into Potree and the Eagle aerial that we have on the JavaScript.
I was going to say, I bet the laundry list of all the other use cases are growing for you.
It is. Every time they come in, and I have written, especially the 360 viewer, the one that I showed you, that was the 4th iteration. It started with just 1 mark, and then they're like, hey, can you do this? Can it work like a Google Street View where I can click on a sphere and go to the next one and see the shots in there too? So it's very, very, very interesting.
So is there any questions from the group? And feel free to unmute yourself and ask them, or you can go ahead and post them in the chat window.
Yeah, I have a question. Thank you so much for your presentation. I know you mentioned that you have a background in programming and computers. I was just wondering, I know you mentioned there was JavaScript behind this, but is there any other programming behind all of this that you wrote, and how much? Just a rough estimate. Was it 1 day's worth of coding or a month's worth of coding? Kind of the behind the scenes of all of this.
Right. I don't think this is one of the most complicated apps. I think the hardest part here for me was how to get into the Potree viewer and extract those X, Y's, and Z's, because I didn't write that part. And the div you see here, it's just a small HTML form. It's easy. And the other JavaScript that was done inside without the Esri API was just the calculations after I extracted the X, Y's, and Z's. And that was done inside the Potree viewer too. If you guys, I'm going to keep on answering this question, but if you want more details, you guys can send me an email. I talked to my boss. They said they're fine, so they can share things with you. And then I combined it with the Esri JavaScript API. I was using the apply edits to create features. And then I would use it to, once we get the slope calculation from the Potree viewer, I would do an edit on the previously created feature and update the slope calculations there. So it's not that complicated, but if you are good at each component, you would be able to do it. If somebody wants to know how to get into the Potree viewer, I can kind of guide you into it, but I think a lot can be done out of it. I think I've only scratched the surface because I'm just using one of the tools at the moment.
Yeah, thank you. And then just one more quick follow-up question. So outside of JavaScript, was the rest of the calculation, was that all done in Python?
Oh, none was done in Python. Everything
No.
is in JavaScript right here. It's
Oh, okay.
Or web-based. My boss here, our county surveyor, loves the web. He said it's so light and I don't have to train people. And we've been doing a lot of cool stuff. If you guys have time, next time I can share some more apps with you guys. So we use it for the land surveys, making arcs, putting the monuments. We do a lot of calculations using just the JavaScript API.
Thank you.
Yeah, fabulous. We have time for one more question if there's one more from the group. Dan, do you have a question?
Well, yeah, I do. I was wondering if you could speak a little bit about the relationship between the point cloud and the photos that you showed initially that had sort of the floating, I mean,
The points inside it?
I was saying it looked a little bit like the Google Earth Street View when you had those sort of floating dots, but then the point cloud was clearly more of, sort of a three-dimensional raster, it almost looked like.
Right. So this app is not using those markers. The reason I showed you that app was just to see what else you can do with it. So what was happening, the points that you saw inside the photosphere can easily be seen on the Potree point cloud viewers too. But once again, the point cloud viewer is the real world spatial reference and spatial projection. So we had to use formulas to translate it into the photosphere form, which was quite close to how they wanted to see it. I'm just showing you different applications to do that. And then I use some event JavaScript events or functions inside the markers in the photosphere where I could jump from one sphere to the next, but that's not all. We had to prepare the data accordingly. I had to sit with the boys and tell them, okay, I want X, Y, and Z for the Esri API or the real world coordinates. I also want the X, Ys for the sphere itself. And then I also wrote something, okay, I'm gonna get the frame ID and I want another table there where I could go and pull out all the markers each time I query. So I have queries within queries that would go and build that photosphere. And what I do is I actually have one URL and I pass object IDs of that feature layer or that feature inside it. And it goes in and it extracts the markers XYs and it extracts the frame XYs. And then I do some more programming inside it to further populate it so it moves. And if you guys want more details, feel free to send me an email and I can share things with you guys. If you guys think it's interesting.
Absolutely. I mean, I think, again, the uses for this is unlimited and it just, as you talk, I'm just thinking of more and more ideas. So I appreciate you sharing with us and the group the amazing work you're doing.
Thank you very much.
Okay, so at this point in time, Fizza, thank you so much. And I know you have to duck off. So thank you for talking and sharing with us. And now I would like to turn over the sharing capacities to Amanda Miner. And Amanda, go ahead and you can grab screen control.
My name's Amanda Miner and I graduated in 2015, which feels like a lifetime ago, although it wasn't. So much has happened. And I was going to talk to you today about the GIS projects that I have right now in Africa. Right now we have projects, I have multiple projects in Ghana, a project in Uganda, one in Kenya, and one large one in the Central African Republic. So, so there's a lot of needs for safe water in the developing world, and this is the area where I've ended up in. there's a race to 2030 to meet the Sustainable Development Goals. It's not going so great, especially in the water sector. So, you know, one of the things that they're lacking are planning tools for installation, management and maintenance of water infrastructure like we have. You know, most local governments here have Esri apps, and they're going out and monitoring and maintaining their stuff using GIS tools. They have not yet been implemented there. The ability for them to map piped infrastructure is a big deal, and household connections. And the other thing is some of these are kind of safe water enterprise situations where they're actually selling water, and so they want to have the ability to map customer locations and optimize delivery routes, do marketing, socioeconomic demographics for their sales territories, and understanding the customer's ability to pay, because over there, that's, you know, a huge deal. And then who needs subsidies and where do we get those grants from? And then the other thing is managing the sales teams themselves, and then they have an installation timeline. They're trying to do some focusing on customer service, so that's being tracked too. But again, there were no tools existing for doing any of this. And then there are the bigger picture challenges for GIS and data across Africa. Data collection and data quality is a really big one. They rely on old mobile phone GPS in large part. And there's no satellite augmentation system for the African continent yet. So they're, you know, I hope it comes at some point, but right now, you know, the level of accuracy that you're getting with cell phones is really not very good. There's very little understanding of GIS among the NGOs, you know, and the local communities, and how that can help. They're very much into their monitoring and evaluation, but they don't understand why they need to think spatially and how that could be. They're very focused on this form-based data collection where, you know, there's no maps involved. It's just a form that they fill out. It collects a lat long and you get a point. That's the extent of what they think GIS is for the most part. And then the other problem that we have is, if you imagine you're trying to, say, collect your well data infrastructure and then go the following year to monitor it, that means with those form-based systems that a new point is taken on every visit. Now, if you can imagine that the margin of error on each of those is like 28 plus feet, you end up with a scattering of points for one well location. And you're like, well, which one is the correct one? And new data often gets collected on the wrong well because of that, and all of that kind of stuff. So data management, there's no real plan for data, for having a schema for. There's just a lot of unnecessary post-collection cleanup that wouldn't need to happen if data were planned. Over there, proprietary systems are really not sustainable. Most of my projects, if they had any GIS involved, they had an Esri grant for a couple of years and then it went away and they couldn't sustain it. So all of that is gone. They're not using it anymore. Internet connection, a lot of the places I work in are rural. And so, you know, that is an issue that has to be overcome, because nobody's going to sit there and wait for an app to load over and over and have it fail. It just, nobody would use the tools. And then the other thing, we started looking into open source, but open source software code doesn't maintain itself. So, you know, we needed something to solve these problems. We needed something highly configurable, cost effective, and be flexible enough to meet the needs of different teams in different places. And you wouldn't believe actually how different some of these places are, not just geographically, but just the way they work and things like that. So, so my challenge, obviously open source was the way that we were going to go, but the right platform just didn't already exist. So I went on quite the learning expedition for, I would say, about a year, learning about, maybe longer actually, a year and a half, learning about open source, teaching myself Linux and the command line interface, and building virtual servers and installing open source software on them. You know, you can read the list, but I reached out to so many open source developers, and I will say the open source community is phenomenal. so many people responded and gave me their time. But at the end of it, I realized that, I didn't have the bandwidth to be maintaining code base as well as trying to solve these problems. And, someone would need to maintain the code and the databases in perpetuity, or the applications would end up dead like every other tech effort in Africa. There's so many issues, so many of these projects that have started, and people will use them for the duration of the project, and then they just get abandoned afterwards because somebody has to maintain it somehow. So our solution is what we call managed open source. We partnered with a team of amazing special developers. They're actually up in Canada, and they're so far north that I actually call them my elves, because they do all the work. They're up near, close to the North Pole. It works. And they magically fix things so that I don't have to, which I love. And so this platform is built on really well-known and well-maintained open source software and configured into one platform. This team then maintains the code base for me and the database while we configure and we'll code on top of it to, fix, adapt, tweak the look and the feel of the applications. They'll develop new software for us, but then that becomes available to everybody because that's how open source works. So the components, you may have come across some of these. Map server has been around for a really long time. These guys who maintain this are long-term contributors to map server and Postgres, PostGIS. And then there's open layers, and I just got an email while Fizza was talking that they've got my mobile app built. So I'm chomping at the bit to look at that. So the result essentially is we've got a web mobile GIS ecosystem for minimal cost with continued tech support for the team. So I can hand it off at some point and then go help solve another problem, but knowing that the people that I've worked with will have long-term tech support, and if they need something new, they can get it done for them at a minimal cost. And also the biggest thing is on this platform, not only can the mobile function offline, but the web apps can function offline too. They have a feature called Undock, where you can take it offline and open the app in a browser, and it just maintains all of the data in the cache so that you can, and then later when you have bandwidth, you can redock it. So that way, teams that are out in the middle of nowhere, they have some capability of interacting with this thing. So anyway, I thought I'd show you some project examples. So this is by far the project with the biggest geographic extent. It's about 2/3 of the Central African Republic. And basically this project, it has many factors, but the big challenge is the infrastructure management, the installation, the maintenance, the operations. They do new borehole drilling and well installations. Some of their operations are, they go on these trips and they cover like maybe a third of the country in one mission or whatever it is. So they have to plan these trips and the logistics. So they need planning capability for that. They need all the teams to have access to the same data. So they have 2 offices that have some amount of internet connectivity, and then the rest of the teams they have like very little to nothing. So this is one of those cases where they really need the team to be on the same page, but it's a really big challenge but right now there's like 1, maybe 2 people in their entire organization that have access to the data. So that means that it's not really augmenting the team's capacity if only 2 people can have access to the data until that data gets processed and then spit out as a report, and then they finally get to read it 2 months later. So these guys are starting to do some drone imagery, and that was another reason why they needed some GIS capability. They were having problems with what I mentioned before about a new point being taken every visit and that being moving around. They've started to focus on piped connections as well as the drone imagery, so that they want to be able to digitize those, have those pipe systems mapped. They have these really complex like solar array things. So I'm trying to think about how best to visualize that in GIS. And they do incredibly complex engineering charts that come out of that too. So that's another thing on the back end. And one of the things I didn't mention about the system we have is it has, do you ever remember crystal reports? Do you ever come across that? It was like yeah, okay. So that's built into the back end of this. JasperSoft is essentially what it is. So we can actually spit out reports from this system too. So this was kind of a summary. I actually posted this on LinkedIn a little while ago. So, we can now represent their imagery and their terrain, the map of their infrastructure status, including the pipe networks, the pumps, the tanks, the taps, all of the features that they want to display. This is like a summary of one of their trips where they wanted to look at, the mileage that they've done, the fuel expenses, things like that. And then they also wanted the capability to be able to map like the population and how many people they're serving within a community. And so we took some raster population settlement data, and then we polygonized it and buffered it a little bit to smooth it out. But we essentially made polygons of all the communities across the entire Central African Republic so that we could do this calculation. It took a while. Even automating it took a while because it's not perfect everywhere. So we also work with safe water enterprises, and that kind of, I felt like I needed a little bit of an explanation because I'd never heard the term before I started working with these groups. So it's a decentralized approach. So that the government's not involved, it's throwing it out to the market to deliver safely treated drinking water, through entrepreneurship essentially. So we work with two types of safe water enterprises. The first is like bottled water franchises where they will deliver all over a city. So those are more urban based. And then we have the semi-rural community installations and sales. So they're doing piped household connections, kiosks in the center of a community. And they have sales teams that go out door to door, and then they sell these services, and then they will actually like trench and put pipes in. The challenges I mentioned a little bit before, there's no objective intelligence for marketing analytics. So, where do you target? And especially when you're dealing with cities like Nairobi and Kampala, massive, dense, the slums, there's very wealthy parts. They really need that information. They actually right now, well, until recently, one of my teams did not have any location data for customers across the whole of Kampala. And I was like, okay, we have to rectify this. So we're trying to rectify that right now. Sales are occurring constantly in the wrong sales territories. And when you're dealing with an enterprise situation, there's a lot of fighting between the delivery guys. And then the other thing is there's no way of viewing engineering data pipe systems over imagery. So they're designing these systems, and then when they overlay them in real space over imagery, they don't align. They go through houses and all kinds of crazy things because the GPS they used is not accurate enough. So, and then of course, there's always the connectivity problem. It's always there, no getting around it. So here were a couple of examples. So for the marketing aspect, one way that so we didn't have to have raster data bogging down the web apps. And so that teams, the sales and marketing teams could kind of have an idea of like densities. We made these hexagons that are 1 kilometer square, and each one has information about the population, about the addressable market, which is defined by them. They want to have a certain number of population minus those living under the poverty line. So that's how they address addressable market. And so we did those calculations, and then we put them underneath their franchise zones so that they could see where the optimal areas within their franchises could be targeted. And then there's the delivery routing. So you see this kind of configured motorcycle slash ATV, they call them tuk-tuks, and they zoom around Kampala and Nairobi delivering water to people. And so we've started building an app that does delivery routing and analysis, and we made a little tuk-tuk icon from the top, which kind of looks like a chess piece if you have it straight up, but yeah. So so we're starting to do that, and that's a lot of fun. Being involved with it. Kampala is just nuts traffic wise, so they really need this. You should see the GPS data that comes in. It's crazy for this place. So this is the second kind of safe water enterprise. And so what they'll do is they'll put these giant tanks into a community, and they'll either have pipe connections to structures, or they'll have like a standing tap pump there where people can go and purchase water directly. So this is a map that an application that we made for the field sales team. And so what they do is they go door to door selling household connections. So these green lines are the main lines. And then, once they've sold, they're in early stages right now. So these contacts, when they become customers, it becomes a happy little blue man, but they haven't got that far yet. And so then we also have the connections to the main pipeline showing as well. But it's just a regular form, but it is map-based. And then this is where, when I was speaking about the crystal reports, the Jasper soft that's built into the back end, we can, from the application, it will spit out these really nice invoices and receipts that they can just give straight to the customer. So yeah. So there's one area that gets a little forgotten in WASH, which is water and sanitation. And that is the healthcare facilities. There's a lot of focus on the general population, but clinics and schools often get overlooked. And so this is just a little kind of, whoops. How do I go back? There we go. Sorry, I clicked something. So this is based on the CDC's evaluation in a local community that we've been working with. And they do them every 2 years. And so they come back and they have these data report cards. And so what we did was we took them and tried to make them more like user-friendly and visualized, basically, not just an Excel spreadsheet like it was. It aids discussion between the local government and the clinic managers, because they have to then, once they get the results, then go and have discussions with them about what they're going to prioritize next. So there's all these kind of standards in WASH with the metrics that they collect and display. JMP standards are what you see here up at the top on the sides. Obviously, you can see that this community is not doing very well. They have basic water, but no hand washing, sanitation, or waste management services. I mean, they have a little bit, but it doesn't meet the standards. So I couldn't not mention healthcare facilities just for that reason. It just gets forgotten. So we are trying to work with the CDC on a potential project in Zambia coming up to do something similar, but maybe build more of a system that tracks this over time. Okay, so our current project, so COVID kind of changed a few things. And so a lot of the funders now, because we get grants to do these projects, so the funders are now saying, we only want to can't speak today. We don't want to fund resilient projects. And so can you help us kind of with this whole assessing resilience? And so, there's a real big need for planning. There's, like I said before, there's a lot of monitoring and evaluation for teams that come in and do humanitarian work, but there isn't the upfront planning. And I think that that's why the need for GIS has been missed. They don't think they need it because they've kind of bypassed the planning stage. They go in with an idea and they say, we're going to achieve this. They haven't had all of the information at the front of the project to be able to plan with it. And so what we're going to be doing is a project where we are doing risk assessments so that we can have some pre-planning instead of all this reactiveness to a problem. So this is just a quick example of one community where I just did a flood. This is flood risk to 2050, I believe, in this community. And then you can overlay it with population. And then there's the most vulnerable population, which is populations under 5 or over 60, and then the low socioeconomics. And then you can start kind of dialing it down to going, okay, which is the highest risk area and what can we do to help? And this actually happened earlier this year, right after COVID. This poor community got massive floods. So, they're dealing with COVID and they don't have hand washing, and now they're exposed to all this waterborne illness. So it's a big challenge. And, the way we've been doing it is kind of backwards. So, obviously GIS has so much value thinking about geographic context and how, and the implications of that for, we need to plan. We have to plan. We have to start planning and looking at things in the whole context of geography, not just this sector, this wash sector, this disaster management sector. We've got to start thinking about things the way we do here, be culturally appropriate. So, all right, that's my spiel. So thank you everybody for listening. And if you have any questions, I'll try and answer them.
Thank you, Amanda. That was great. I know this group has some questions here, so I'll give you guys a moment to unmute yourself.
Hi, Amanda. This is Diana.
Hi, Diana. How are you?
I'm good. How are you?
I actually know Diana. We've been chatting a little bit offline, but yeah.
Yes, Amanda is great. I had a question. So I know you're talking about the sort of like the network analysis for delivering the water. And so I guess there's the network analysis of the people, riding the tuk-tuks and delivering them. And then I was wondering if there's a step before that might need a network analysis as well of getting those delivery people the water that they need to deliver. Is there any consideration for, the step beforehand and then kind of the network analysis there and maybe making that process more efficient?
In terms of, do you want to repeat your question? I'm not sure I quite follow about the pre-analysis.
Yeah, sorry. So like in order for the tuk-tuk delivery people to deliver the water, they need to get the water themselves.
Oh, okay. So you're talking about getting the supplies before they go out there?
Yes. Mm-hmm.
Okay, gotcha. So those are usually delivered to, they have franchise stores. Within each franchise, there's a designated store within that. And so the water gets delivered to them, or the bottle to them site, because they have like chlorine generators and stuff, I believe. Although I do think there are a couple of locations where they do it differently and it is delivered. But there is some concept of delivery, but we haven't really focused on that per se, because that wasn't the problem area for this particular team. But that's a really good point. I will mention that, because I'm not sure where the bottles ultimately come from. So yeah, no, that to answer your question, that hasn't actually been a discussion. This is more about getting those customer locations because we didn't have them already. And then right now they're just zigzagging all over the place and they're not optimally visiting these customers in a way. And they're actually losing business because someone will call up and order water, and because they don't know where anyone is and everybody's all over the place, they can't get a hold of anyone fast enough to reach that person. Or if someone does come, they're like really far away, so they weren't the most efficient person to come. It's just complete chaos. And then if you've ever, I don't know if you've ever seen the traffic in Kampala and Nairobi, it is insane anyway. So, but the customer then just calls another company that's also selling water, and then they've missed out on sales, and that happens way too much. That's what started the whole project, actually. So.
Gotcha. Yeah, thank you. So it's probably a tackle one problem at a time kind of a thing.
Pretty much.
Do that one first, and then we'll worry about the other step.
Yeah, I mean, you're right in terms of you want to think of the thing holistically, but usually the way these projects happen is someone will approach us with a specific problem, and then as we see other problems, we try to encourage them to deal with all of them at once. It doesn't always happen. You kind of have to have the buy-in, but yeah, for sure.
Thank you.
You bet.
All right, Amanda, a question was just emailed to me. And this question, the student would like me to ask if, do you travel to these locations and pre-COVID, or how often is the GIS team traveling there, or is a lot of the field work, is it happening from afar?
Okay, so for these projects, these water projects, we have been doing it remotely because we have teams on the ground that we've already trained to go, like, who live there. Because one of the things that we believe in is building local capacity, right? So I would love to go there. Obviously, COVID happened. We're almost a year now, right? So that's been, and this has been sort of like a 2.5, 3 year thing. So if we have teams on the ground, there's no need to travel, but it's getting to the point where we're seeing such a need in some of these areas that once post-COVID, hopefully someday, we probably want to get out so that we can train more people and build more capacity and liaise with the colleges and universities and really build GIS as a capacity there. So one of the big things that I always tell clients, and we really believe this here, is we don't want to make anyone dependent on us. We want to give you the tools, and then we move on. There's plenty of more problems. We don't need to make people dependent. I'm seeing this so much. This is where I feel I have to say it. I see it so much in the humanitarian sector that tech will get these groups, these NGOs, these local governments to sign on to something, and then to be able to move their data or get their data out, they have to pay more money, or they can't connect APIs because they don't want to. And I don't want to get anybody stuck in that situation. So, the goal is to build as much capacity within that project as possible and then move on to the next thing. So the only way to do that is to actually build local capacity. It would be great to travel, and I think in some ways it would make things a little easier, but at the same time, this is forcing that to happen, which is a good thing.
Thank you.
Sure.
Anyone else have any questions? I have one more if anyone doesn't have it, but I want to open it up to folks that are here. Okay, so my last question, and this actually is built upon Diana's question in the preliminary steps, thinking about needs prior to the delivery aspect. My question is now, the processing or recycling of the, gray water. Is that something that is happening now? And is there plans in place to move the water back for processing, or no, not yet?
No. So there's the clean drinking water, which is the main focus of WASH, honestly. There's very little focus on sanitation. It's becoming more, and I think that whole gray water thing would become more under the whole, what happens afterwards and how do you reuse and recycle. But that the problem of people having safe drinking water is so seemingly unsurmountable that no one can focus on things like that, like what do you do with it afterwards. But obviously it needs to happen, because there's going to come a point where they're going to have to turn and then also look at the other 360 problems, right, in the geographic context of the ecology of a place, and they're going to have to meet with the environmental people and actually solve those problems, as well as, you know what I mean? It's just too sector driven. And so for this clean water and sanitation, it really does just focus on drinking water, toilets, hand washing. Really, those are the main things. Yeah, it's tough. It's what they call wicked problems, right? Really, really wicked.
Right.
Yeah.
Well, I just want to thank you so much for speaking with us here, and really thank you for the mentorship that you offer to the community of GIS. I know you're involved in Women in GIS, and just really thank you for doing that and being involved. So
absolutely. Yeah, that's how I met Diana.
Yep. Yeah, thank you, Amanda. I can't thank you enough.
Yeah, no worries.
All right. I want to remind everyone that we will have part 3 for GIS After Dark, and it's going to be on December 2nd. And we're going to be joining forces with a speaker series called Nexus, and it's focusing on food, water, and energy nexus. And so the speaker for this series will be talking about, and this actually feeds in nicely to Amanda's presentation. It's Dr. Paul Sullivan from Johns Hopkins, and he's going to be talking about the security of water and the importance of water in places like the Middle East, and in China and in India, but he's also going to touch on the third pole, which is the glaciers in the Himalayas. So it's going to be at a different time. It's not going to be GIS after dark. So it's going to be hosted at 2 p.m. Eastern Standard Time on December 2nd, but we'll be co-hosting the series. So I welcome those folks that want to solve problems in the water sector, because it's going to be a very important problem to solve in the near future. Please join us at that time, and I'll send out an invite to the group. And again, you know, Amanda, thank you so much for being a part of this, and Fizza, who's not here right now, but again, you two were the first alumni to be a part of this speaker series. So again, thank you very much for your input. And folks attending, Amanda and Fizza has shared their contact information. So any additional questions, please feel free to reach out to them. Also, I've provided my contact information below. If you have any type of industry that you'd like me to pursue in bringing folks in, please reach out to me. I'm always curious and interested in you know, learning different aspects that, and I can definitely reach out to. So thank you all for attending tonight. I know we've been definitely seeing a lot of maps in the news and a lot of GIS and analytics and statistics. And I want to say happy GIS Day early, since we will not be meeting before then. And I hope everyone has a wonderful evening. Thank you.
Thanks.